So why does anyone care about concavity? It's actually a really good question. Concavity corresponds to acceleration if you're looking at a position function. So if you have f of x gives the position of an object, then f prime of x will give the velocity of the object, and f double prime of x will give the acceleration of the object. So in looking at a curve, you can tell what's happening with the acceleration of that object by looking at the concavity of the curve. So again, if f of x is equal to position, f prime of x is equal to velocity, and f double prime of x is equal to acceleration. So if you're trying to tell whether an object is moving forward or backwards, you use velocity. And you determine when the velocity is positive or negative. If you're trying to determine when an object is at rest, you use velocity and you determine when the velocity is equal to 0. But if you're trying to determine when an object is speeding up or slowing down, that is the second derivative, that is position. So, I'm sorry, that is the second derivative, that is acceleration. And so concave up on a curve corresponds to speeding up, concave down corresponds to slowing down.